This lesson deals with Supplemental Problem 5.4. You can find this problem in the course ebook in the Chapter 5 Supplemental Problems on page 4. Given a differentiator circuit with a series resistor we're going to ignore for right now, and a value for V sub S that looks like this. It goes from minus 2 volts to plus 2 volts in half a millisecond, and then from 2 volts to minus 2 volts for another half a millisecond. Just repeats itself. A period of 1 over 1 millisecond or 1 kilohertz. Can you take that waveform in this circuit and predict V out if we ignore the 200 ohm resistor? I'll explain that in a little bit. For a differentiator circuit, V out is equal to minus R2C1 times the derivative of V sub S dt from our last supplemental problem. The value of R2 was 10K. The value of C1 was 0.1 microfarad. What's the derivative of V sub S? Well, it's just going to be the rise over the run. Here I've got a rise of 4 volts, and the run is a half a millisecond. My value of dVs dt is 4 divided by 0.5 milliseconds. This is between 0 and half a millisecond. It repeats itself from 1 millisecond to 1.5 and so on. What's the derivative of V sub S between half a millisecond and 1 millisecond? It's going to be the rise over the run, but now the slope is negative. I have a minus 4 volt change divided by half a millisecond. That'll be between half a millisecond and 1 millisecond. It's going to repeat itself between 1.5 milliseconds and 2 milliseconds and so on. In this first interval of half a millisecond, the value of the voltage V out is going to be a minus R2 C1 times the derivative of V sub S with respect to t. When you multiply that out, you get minus 8 volts. And then our other case was minus R2 C1 times a minus 4 over half a millisecond. That's going to be a plus 8 volts. Let's sketch that. Between 0 and half a millisecond, we have minus 8 volts, then plus 8 volts, and so on, repeating itself. So we get a square wave. Now the resistor that was stuck in series is called a compensation resistor. The non-ideal effects of the op-amp cause a problem with this circuit. Putting that resistor there, it pretty much acts ideal. Without it, it becomes an unstable circuit, and the output hits the power supply rails. This is Supplemental Problem 5.4.